Okay, this is section 6.3, number 5. It says, commercial fishermen rely on a steady supply of fish in their area. To avoid overfishing, they adjust their harvest to the size of the population. The formula R equals 0.5x minus 0.0002x squared gives the annual rate of growth in tons per year of a fish population of biomass X tons. So part A, we're asked to find the vertex of the graph, and we can do this one of two ways. Okay, the first way is to use the vertex formula, where it's x sub v is equal to negative b over 2a, and we look at the coefficients in the given equation, and so A is really this negative 0.0002 because it's the coefficient of x squared, and B is 0.5. So that gives us negative 0.5 divided by 2 times negative 0.0002, or 1,250. Okay, to find y sub v, the y-coordinate of the vertex, we're going to substitute 1250 for x in the given formula. So 0.5 times 1250 minus 0.0002 times 1250 squared, okay, which gives us 312.5. So altogether the vertex is the ordered pair 1250, 312.5. Okay, another option is to graph this function in y1. Okay, adjust your window to match the window given in your graph grid, and then hit graph. We can then locate the maximum of this quadratic just using the max feature. So it's second trace, number 4, and you just want to scroll. It'll give you some prompts at the bottom of the screen, so scroll to the left of that vertex and hit enter, and then scroll to the right and hit enter, and then press enter one more time. And so here it is when x is 1250, y is 312.5, and that is the highest point of the graph. Part B, it says find the x-intercepts of the graph. And again, we can kind of do this one of two ways. The x-intercepts occur when y is 0, so we can substitute 0 for r in the given formula and try to solve this equation for x. We'll factor out a 0.0002 and an x, and we get 2500 minus x as the other factor. And then if you set each of those factors equal to 0 and solve, we see that x is either 0 or 2500, and so those are the x-intercepts. The other option, if you've already graphed your function, you can enter a 0 in y2 and then find the intersections of the curve with that line. Okay, so under second trace, intersect number 5 and hit enter 3 times, and there it is. One of those x-intercepts is at 2500. So we're going to write these x-intercepts as ordered pairs. And so the first one is 0, 0 at the origin, and the second is 2500, 0. In part C, we're asked to sketch the graph, and so we're going to make sure that our curve passes through these points. One is at the origin, so the x-intercept, which happens to also be the y-intercept of 0, and then 2500, 0, and then the other is the vertex, which is at 1250, 312.5, and connect those points with a curve. And the graph will look something like this. In part D, it says, for what values of x does the fish population decrease rather than increase? R represents the annual rate of growth of this fish population, and so when the rate of growth is positive, the fish population is growing, and when the rate of growth is negative, the fish population is declining. And so we're looking for when the annual rate of growth is negative, and that would happen for these values of R that are below the x-axis. And so we're going to start here at this x-intercept, and then say from there on is when that the fish population would decrease. And so we'll write it as an inequality. We'll say when x is greater than 2,500, in interval notation that would be from 2,500 to infinity.